Sometimes it's handy to be able to determine how many digits a number has. And in the case of the problem we were doing called DigitsDisplay, you need to know the power of 10 corresponding to the number so that you can divide by that and extract a digit. So given a number like 2345, 2345, the corresponding number that you would want to divide by to get the 2 would be 1000. And if I run it again, I want to produce the corresponding base 10 number uh, to the number of digits I have. So this one has 5 digits, so it should be 1 and then 4 zeros. So I can divide by 10,000 to get the 1 from this number. Anyway, so back to the problem. So there's 3 different approaches that I wanted to show to get the number of digits and produce this base 10 number with the corresponding number of digits that you need. So approach number 1 here is to start with the highest power of 10 that fits into the int range for Java. So that number happens to be the maximum int value that you can store here. Is okay, that's million, billion, trillion to 2 trillion, 147, blah, blah, blah. So if you make that one value, a base 10 power that is within that range, it would be this number here. There's 9 zeros on there. Okay, so we could start with the maximum base 10 number, and then we could just keep dividing it by 10. In Java, that gives you an integer value, right? So it truncates the decimal part, and it would just knock off a 0 each time it divides by 10. And the number gets smaller and smaller, approaching 1. So we could do that in a while loop while the power of 10 is still bigger than the number that I typed in. So this first number with 9 zeros is definitely bigger than 12,389. So it's going to then knock off another digit, and keep going down. So by the end of this loop, it should be the right number of digits. Approach 2, let's just look at this for a second. We could do it a lot simpler without using a loop at all, but you have to know what logarithms are. So logarithms help you solve equations like what power of 10, like 10 to the power of some number x, equals a certain number, right? So that's using log base 10. So that's going to be a decimal number, a real number. So we need to, in the end, make it into an integer value, which is truncated or rounded down. So if you take the example of 346, you might say, well, what power of 10 to what number gives me 346? It's not exactly this number, but 10 to the 2.539 is going to something is going to give you that number 346. Now, if you want, you can then round that to truncate it down to 2. So, and that 10 to the 2 would give you 100, which is the right number for that I would want to divide this 3-digit number by, right? In order to get that leftmost, most significant digit. When I divide by 100, I get a 3. So anyway, so this is how you could do it. You could say, use a math function or a math class and use its log 10 method, give it the value, like the 346 or whatever you typed in. It's going to give you that weird number, so you got to take the int of it, which truncates it down to 2, and then you can store that as your exponent. Then you can work out, okay, math.pow of 10 to the exponent, whatever you worked out, 2, for example, gives you 100. Since this is an int variable, I had to int the result because math.pow always gives you back a double. Okay, approach number 3, if you haven't had enough yet, you could do the opposite of the first approach, which is to start at the lowest number, power of 10, which is 10 to the 0, which is 1, and we could increase until we hit the right number of zeros. So it's going to produce in a loop 1, 10, 100, 1,000, 10,000, etc. And we want to stop, obviously, when we've got a number, one of these numbers is exceeds the number that we have. So in the case of 346, we would say, well, 100 is not quite there, so it would loop one more time and produce 1000. So in the end, we have to kind of scale back the number by a factor of 10. But so let's start pow 10 at 1, the lowest power of 10. In our loop, we're just saying, well, pow 10 is less than the number. If our number is that 346, then we'll have to loop and multiply by 10, which makes 1 times 10 is 10, goes back up, still less than the number. Then we have 10 times 10, which is 100, still less than the number, and then multiply it by 10 again, it becomes 1,000. And then it exits because 1,000 is bigger than 346. So then we would have to compensate by dividing it by 10 to knock off one of the digits, because it's always going to be too high by one digit, by 1 power of 10. And as we see, we printed that and it worked. So yeah, so that's the way to do it. If you wanted to see one of these loop, you can always double click to make a breakpoint, and then you can say run debug, and it's going to switch to the debug perspective after I type in my number. I first have to, I guess, step into this. Did that actually run? Yeah, okay, here we go. I don't know why it's so slow. 1, 2, 3, 4. Enter. Switches to the other perspective. And see, this is the number of the POW 10 that I started with 9 zeros. And you can see in my loop, we'll just watch it go for a couple loops. So it's going to start the loop and it's going to divide POW 10 by 10, which would knock off a 0. You can see it got smaller, and it's going to continue that process until it is, now at this point it's going to go less than the number. So this is now false. This condition, POW 10 is not greater than the num value, which is 1,234. So it should exit, and by the time it exits, it had the right number, 1,000. You can see this one here also is going to do, say that there's exponent from the logarithm is 3, which is the power of 10 that you need. 10 to the 3 would give you 1,000. So that would be the exact same number we produced the first time. And then the last approach is to start the thing back at 1 and just keep multiplying that by 10, and it's going to be 1,000, and then 10,000, which is bigger. So this while condition is false now, so it'll exit out, and then it'll knock 1 0 off that to be 1,000, and that's the right number that we're looking for. So 3 different approaches. Pick the one that's most understandable for you and go with that one. And now you're ready to use that number to extract the digits. So this is only the preliminary part of solving that digit display problem.